Hi, my name is Francisco Rodriguez. I'm from Wolfram Research, South America, and I will talk about geodata and will focus on vector geographics. So in this presentation, we'll talk all about the data that is behind this new vector geographics, all this technology we have been developing to support this. This is a small outline of this presentation. Okay, so this is the map you get for GeoGraphics here. Then here we have the traditional GeoGraphics map, which come with raster tiles. It means that we have in the server bitmaps of every tile in the world. And for the ones we don't have that, we generate that on the fly. Because of course we cannot have that many tiles because we need that up to Zoom 18. Now we have started this support for vector geographics, which look much better in the sense that they are actual primitives rendered by your computer. So you can resize, you can see how sharp all the lines should be, because they are going to be rendered by your client. So this is for exactly the same area, using the same zoom. So that's what we should be able to do now. So let's see some examples. And as introduction to all these examples, we have added now also various styles. So in order to access this new vector geographics, you can use the geo background option. So instead of using street map, no labels, etc., now we have added vector classic, vector default, vector business, vector marketing, minimal, monochrome, web, and vintage. So the idea is that now with these geo backgrounds, everybody will be able to get these vector maps. So this is a small set of all the world map zoom level 0 for all the styles. So street map is the current geographics, and all these are the new styles that will be available. We are still working on all these styles, so expect some changes from what I'm showing right now, but this is a preview. So also something very nice about these new vector maps is that we can have now projections without distortion. So for the raster maps, for example, you had GeoGraphics, which by default, for example, when you use a non-equirectangular or Mercator projection, uses the no labels map, because when you add the labels, when you use the current street map, they get distorted. And that's because the change of the coordinates and how we project the whole Earth map. Now with vector map, we can ask for the projection, and using this new GeoBackground Vector Classic, it will show very nice all the labels without any issues, because they are added as actual primitives. So these are text elements into this graphics box. So let's see a few more maps in this gallery. For example, at country level maps. At country level maps, you can expect limits between countries, limits between some state names, capital, city names, etc. So this is something that, of course, with the styles, we will be able also to tweak even more to have very nice maps. I have also here the zoom level 4. We have many zoom levels. I will explain that a bit later. So for example, for United Kingdom, with a different style, I will be using different styles for each map so that we can appreciate them all. And we can see how the coastlines are sometimes a bit, let's say, simplified, and that depends on the zoom level we choose. GeoGraphics will try to choose the best zoom level for each map so that it doesn't have that many data. And for example, a smaller country like Vatican City also looks very nice. And you can see all the elements around, streets, buildings, different blocks, etc. So let's see some city level maps. For example, for New York, well, New York City is very large, so there's not much zoom yet there. Or let's ask for Moscow, and let's for some zoom level. I'm using geoposition to actually look for the center of Moscow instead of looking for the full polygon, because it's going to be larger. As you can see, there are no issues with Cyrillic letters. We can go deeper. Let's go to zoom 15 for Tokyo, for example. There is some center position within Tokyo. Or we can navigate to other cities. Let's go to Stockholm, for example, where we can see the different elements all drawn into the graphics. We can go deeper, like zoom 17, and look for the Tower of London, where you can even see some of the buildings, etc., that are in the data. Or we can even have decimal values for the zoom levels. That's something now allowed, and also something that works smoothly with the vector GeoGraphics. For example, the Central Plaza in Mexico City with some zoom of 17.5. So let's talk a bit about the tiles. Jose has been already talking about how we are merging tiles, etc. So this is a small reminder of how the tiles work. So you know that we are organizing the vector maps also using tiles. And for each zoom, we have 2 elevated to the zoom twice. So this is a very large number for large zoom levels. And when I publish the node, you will see here the code to create, for example, these bounding boxes that represent each tile in different zoom levels. I'm using here maps at different zoom levels and representing which are the tiles that make up this map. So, for example, if we want to draw Europe at zoom 3, we will have this number of tiles. And what will happen if we want to draw this at zoom 4, where you can have more elements, like, for example, more rivers, more limits between states, etc. Much more detail, the cities, capital cities, but you will have a lot of more tiles. So a bit about the zoom levels. So we have zoom levels from zoom 0 to zoom 14. And you can anyway, as you have seen before, request, for example, a map at zoom 16, at zoom 17, at zoom even 24. But anyway, we will use the data from the zoom 14. The difference is that there could be more elements in the sense that the style could define more style layers. I will explain later about the style layers. And then with these style layers, they can choose different elements from the same tiles. And of course, the total number of tiles in the server is going to be this large number. And that's enough to cover all the data in the world. So that's several gigabytes of data in the servers. So yes. And to optimize a bit how these tiles work, we are using what we call meta tiles, That's something that also the Raster server uses internally, but not externally. But in this case, we are using that. We are developing that in the client side. That means that we are grouping the tiles in groups of 8 by 8 tiles, such way that, for example, this map of Europe that used 70 tiles, regular tiles, now uses only 2 meta tiles. In that way, even when the total download size is larger, the times you do request to the server is much smaller. So it means, in general, a better performance downloading the data, and also allows you to, for example, if you do several maps, it will have the meta tiles in the cache of your client, so it will work faster other maps. Okay, so how about the tiles itself? We are using the Mapbox vector tile specification as format for the tiles, which is encoded using the Google Protocol buffer. And in general, each tile is a collection of layers of data. This data is a set of features, and each one is this basic object, like, for example, a line, a polygon. So the content of each one is a type, which will say if it's a point, a line, or polygon. The geometry itself, it means the actual coordinates for this line, this point, or polygon. And some key value pairs, which are the metadata of this element. For example, the polygon of US. So that's going to be a polygon type geometry. The geometry will be the actual coordinates, and it will have some metadata like the name, the class, etc. Actually, the borders of countries are not polygons, but lines, because you want, for example, to draw a line between two countries and a different line in the ocean limits, borders, etc. So these are the type. And these key values are actually used by the styles to filter and select the different features. For example, if we want to draw only the capital cities, we can use the class city, and well, there is another key value which says if it's a capital or not. There is a capital key with some value to specify it's a country capital. There are several keys actually for different layers. There could be different keys. So the styles are, we are using internally the Mapbox style specification, and in this specification, the styles are defined by different layers. These layers are actually different from the layers of the data, but could be related. Because, for example, you can have a layer for the names of the streets and another layer for the actual lines of the streets in the style, but these two layers refer to the same data layer of streets, of transportation, it's called. So the main layers, the style layers, are the background, which is actually only for the color of the background, the land color. Fill type layers, which are the polygons. Lines for the cases of borders, for example, rivers, streets, and symbols. Symbol is the layer that holds all the style layer that holds all the labels. So all the labeling goes in the symbol layer. As I said, in general, each of these layers might refer to a source layer. And each one will define some filters, some, let's say, with the key values to pick up which elements from each source layer are going to be applied in the map, and which will use some parameters of paint and layout. By paint parameters, we mean, for example, to choose which color, opacity, if there is a pattern, if there is some outline color for the field case, for example. And the layout parameters are many more, like for example, the line width, line cap and join, some parameters extra for them. Some important parameter for the symbols is where to place the symbol. I will explain a bit more later. Different parameters, like for example, the text field parameter. That means what are we going to use as label. Font style parameters like family size, letter spacing, line height, alignment, how width I want the labels, if I want them to rotate or not, in which direction, if there is any offset, if we want to keep upright the labels. For example, when we follow a line, a label could be upside down, and we need to rotate that 180 degrees, but we might want or not might want that. For example, if we have an icon with an arrow, we don't want to move that arbitrarily. But if we want a text, we want that to be something you can read always. Which icon image to use, how much space between the different symbols, whether there is symbol spacing, text spacing, icon spacing. So there is a lot of parameters that we have, that we needed to implement to interpret all these style layers of these different types. So I created a small function to handle, well, to show how these style layers work internally. So here is a full map of, well, you can see the parameters of the map here for the wall at zoom 2, some size, using Mercator projection, and using this new vector default background. So these are the different types of style layers. So we have the fill style layers, the line style layers, the symbol style layers, well, some extra layers. So let's remove everything. So the background is basically, as I said, the color for the land. The fill layers are all the polygons. In this case, basically the polygons are the ocean and seas, so all the water polygons. Then we have the lines, which for this map kind of boring, only the borders. And the symbols, which are all the country names and sea names. Well, some attribution that it's the tooltip that we always place. And now we can also see the different styles. So for example, we have the background is the same style layer. So these are the style file that we handle. It's handling actually these names in the file. So these are the ones that we are interpreting. These are the different classifications. So there is some ice over there. This is the water. So all the ocean comes as a large polygon. We have the boundaries of the countries. We have, for example, the names of some seas, the name of the oceans, and different layers of names of countries. This is done to, why to have these different layers is to give a different priority. I will explain then in a moment how the labels work. So they need to have a different priority, so they are in different layers. Well, all these refer to different layers in the source. So in the source of the tiles, we have a layer for the land cover, a different layer for the water, a different layer for the boundaries. The water names, here for example, we have two different layers that refer to this same source layer, or the place names, which means that two different layers refer to the same, well, three different style layers refer to the same source layer. And let's see now another zoom. This is, I think, zoom 9 point something. This is for Cebu. You can see here the parameters I used, some image size, same projection. And here we have a lot of more styles. So all this has to be computed by the by GeoGraphics. And well, I won't play with each one, but then you can play with this. So we have, well, let's see, for example, all the polygons. These are all the polygons around the river. It's also this water polygon, the parks, different elements. Lines, there are lots of different lines going on here, and the different types of symbols. All these symbols, we are still working on improving this even more. So you can see here all the different layers. For example, I can choose only the transportation names or only the water names. Well, it seems that some might be outside. And this is something else that I wanted to say before I move on, is that when you are looking at some of these maps with all these elements, actually we have many more elements around. And this is to have, well, let's see if, yes, to have the names, to know that in case some of these names also go inside this region of the map. So this is the buffer that also was talking about Jose, that all the tiles come with some buffer of data. So we can draw them properly inside this smaller square. So let's go over the labels. The labels, it's actually the most, let's say, hard part to implement, in the sense that we needed to implement all this technology to handle them. The labels in general are a text, an icon, or an icon plus a text. And there are different places where you can put the label. It can be in a point. Let's say I have a name here. It can be part of a line, for example, a highway or a river. You can have a fixed rotation, or that rotates following the line, or it can be in the line center. So let's go very quick. I've been already showing. This is an example of point names. So there is a point where we want to place the country name or the ocean name. Line names, for example, to follow the rivers. Here, for example, is a conjunction of Marañón and Ucayali that then converts into Amazonas River. Or along lines, but that don't rotate. For example, shields for the highways, the roads, we don't want to rotate them. So we want to rotate the street names, but not the highways. So this is a different type of placement. So we need to use the algorithm to handle the collisions. For example, if we don't use that algorithm, we will get maps like this, with all the country names, with all the oceans names. For example, for Zoom 2, or for Zoom 14, for example, for Madrid, we have a lot of elements here. So we need to use Jose's algorithm that he already explained a bit in his presentation. So we start with an empty, let's say, a list of used boxes, and then we iterate for each layer. In this list of layers that I showed before, we go from bottom to top and start iterating over the layers. So we compute the bounding box of each layer, of each label, and then if it's a label for a line, we try to compute the best position in each line to place that. Then we call the collision algorithm with all the parameters about the spacing for each bounding box, for all the bounding boxes. And then we select which one are included. And we fill this list of used boxes with the new labels and iterate again in the next layer. So effectively, the priority of each label will be given by the layer it belongs, and also within the same layer, we use the order of the labels as they come. So we need to sort the data in the source if we want some specific ordering. So for example, after applying that to the world, we get these labels, which are only 53 out of the 220 that were here. So here in this first map, we had around 220, but not around exactly 220 labels that were computed. And for the next map, as you can see, there are now nicely only some elements. And here we have 9 different layers of labels, and the collision algorithm selected 202 labels out of almost 8,000 labels. And of course, if you go to higher zooms, you will have many more labels to handle. And all this is done in some milliseconds. So all these collision algorithms is very optimized to handle all these large number of data points. So something else about this labeling of maps is that the labels depend on the map size. So if for the same zoom level, let's say zoom level 3, if you use a size of 200 pixels, it will show only a few labels. If you the same data, the same map parameters with more size will show more labels, and obviously with more size will show even more labels. And something else is that in general the labels are text elements. That means that they don't rescale when you resize. Everything is scaled, but we have also a methods parameter that will allow you to rescale the labels while you increase or decrease. So they will keep the same scale size. That's a method parameter that we will be able to access. And well, we are almost over the time. Before the questions, some of the future work, we plan to extend and improve more the support of vector geographics. We want to allow layer manipulation. Right now it's kind of behind the scenes. Support styles provided by the users, then also support external providers, and eventually allow also direct data access. That's goal for the future. Thanks, bye.